At last, in the fall of 1915, Einstein realizes he's solved it. His great insight is so strange, even physicists will struggle to comprehend it. He proves mathematically that mass and energy curve space and time. A massive object like the sun warps space and time so much that a nearby planet moves in a curved path around it. To Newton, they appeared to be attracted by a force. But this is just an illusion. The same phenomena holds true on Earth. Objects that appear to be pulled by a gravitational force are actually traveling through warped space-time. Einstein arrives at a set of equations governing space-time curvature. These simple lines describe the motion of galaxies and the destiny of the universe. Although Einstein will continue working until the day he dies, by the time he is 40, he has completed his greatest work. Galileo applied mathematics to motion. Newton perfected these laws for everyday experience. But Einstein's search for a deeper theory revealed laws that govern the entire universe. Today, another brilliant rebel is searching for an even broader theory, a theory of everything. No living scientist has shaken the foundations of physics like Galileo, Newton, or Einstein. But among those who have advanced cosmology's frontiers is a once lazy student named Stephen Hawking. Today, he holds the same chair in mathematics at Cambridge University as Isaac Newton.
I was born 300 years after the death of Galileo. I hold the same job at Cambridge as Newton did, and I work on Einstein's general theory of relativity. Of the three, I feel closest to Galileo. He followed his nose and was a bit of a rebel.
Stephen Hawking is born in 1942 in Oxford, England. Like Galileo, Newton, and Einstein, as a child, he is fascinated by how things work. Yet at Oxford University, Hawking hardly works at all. Instead, he relies on his extraordinary facility with mathematics to coast through. In 1962, Stephen Hawking has just begun to study cosmology as a graduate student at Cambridge University. But signs of illness are becoming too difficult to ignore. A slight speech impediment, difficulty pouring a beer. Doctors tell Hawking he has ALS, commonly known as Lou Gehrig's disease. The regions of his brain that control motion are wasting away. There is no cure. The 20-year-old student learns that his body will become paralyzed. His breathing muscles will eventually seize up, suffocating him. Doctors say he has just 2 years to live. Hawking falls into a deep depression.
When Stephen was first diagnosed as being ill, he really didn't expect to live more than a year or two, and therefore there didn't seem much point in even completing a PhD.
But inexplicably, his disease progresses more slowly than predicted. He meets Jane Wilde, the woman who will become his wife. and he finds a purpose. I dreamt that I was going to be executed, he writes. I suddenly realized that there are a lot of worthwhile things to do if I were reprieved. Now Hawking begins working hard for the first time in his life. And to his surprise, finds that he likes it. By the early 1970s, Stephen Hawking is a well-established cosmologist. He is also in a wheelchair. Yet he is remarkably stubborn. Nothing will keep him from living a normal life. He has children, he works intensely, and he is about to make a great breakthrough that will extend Einstein's theory in an unexpected direction. Einstein's theory of general relativity predicts the motion of very large objects such as galaxies. But it cannot explain the behavior of the tiniest subatomic particles that are the building blocks of the universe. Their motion is only predicted by a different theory called quantum mechanics. And to the frustration of Einstein and every physicist since, the two theories appear completely incompatible. Yet Hawking is brash enough to tackle the impossible.
When Stephen Hawking was doing his pioneering work, there were two armed camps. They hated each other. They never talked to each other. On one side were the true blue loyalists, the ones who held the flame of Albert Einstein burning bright. On the other camp were the quantum theorists. They dealt with the world of particles, subatomic particles, hundreds of them, thousands of them, and they didn't talk to each other. They had different mathematics, they had a different language, a different physical picture, and here comes Stephen Hawking saying, I'm going to try to marry the two together. Well, that was heresy. No one had done that before.
Now Hawking asks, what happens if you look at a black hole, a massive object, but zoom in to its smallest scale?
Hawking also, like Einstein, has an incredibly good nose. That he has an intuitive feel for interesting questions to ask and how to ask them.
Black holes are the most bizarre and extreme prediction of Einstein's theory of gravity. Theoretically, if a mass is extremely concentrated, for instance, if a star were compressed into a ball just miles wide, the space around it will become so warped that gravity will keep everything from escaping, including light.
A black hole is a region of space in which gravity is so strong that light can never escape. It's like a one-way membrane in which things can go in, but nothing ever comes out, including light, and that's why it's called black.
Now Hawking attempts something his colleagues assume is impossible. He uses the equations of quantum theory to analyze what happens to tiny particles trapped by gravity on the edges of black holes. By now, he can no longer write. If he was an experimentalist, his career would long be over. But Hawking has rarely even looked through a telescope. And for theory, all he needs is his brain. Like Newton and Einstein, Hawking has great powers of concentration. He reruns long, torturous equations again and again in his head, checking and rechecking his calculations. Hawking's results shock him. Black holes are not completely cut off from the rest of the universe, as once believed. Instead, their edges shed tiny particles, now called Hawking radiation.
The arguments are so compelling, everyone now agrees that black holes must give off Hawking radiation. The radiation will carry